Right, in this video we're going to talk a little bit about the circle. Some very important things you should know. Now some of these I might have covered in another video, but we'll go over those just in case for review. So we're going to talk about area, the arc length, chords, angles, and more. So let's suppose that this right here, this vertex of this angle that I have here, is the center of the circle. Let's talk about that first. This then would be considered a central angle. So let's label this center point here C. Say this is A, this is B. So I'll label the arc AB. So this will be arc AB. And the measure of this arc, say, is X degrees. So talking about this arc right here, X degrees. Then what we need to know then is the measure of angle C. That's a central angle. Central angles have the vertex at the center of the circle, and then they intersect over here. The sides of the angle intersect at the circle, in this case A and B. The measure of this angle C would be the same as the measure of the arc that it subtends. So if this arc measures 40 degrees, then this angle would be 40 degrees. That's a central angle. Another thing to keep in mind is that the radius of the circle is given by segment AC. Segment AC, this would be R. Now if I extend this side like that, that's a chord of the circle. And the diameter, that would be the diameter there, labeled by D. Diameter will always be twice the radius, or the radius will be half the diameter. This right here, label this point as E, and this one over here is F. That's a line segment. I'll denote it by EF with a little bar. That's a chord. So any line segment that has an endpoint, one endpoint on the circle, and the other endpoint also at the circle would be considered a chord. So EF is a chord. And this length of this diameter here, label this point over here G, then AG would be a diameter. Now the other thing we went over is the area of a circle is always pi r squared. The area of the circle, all I need to know is the radius. Obviously if they give me the diameter, I know that the radius is half of that, so it's easy to find. So if I have a circle and the radius of the circle is 5, just plug it into there, and the area of that circle, 5 squares 25 is 25. This is your exact answer, and that would of course be square units. Area is always square units. And of course if you want an approximation, you can just use your calculator, multiply 25 by pi, use 3.14, so just use the pi that comes into that's in your calculator. It's more accurate. Now the circumference of the circle is 2 pi r. That's like the perimeter distance around the circle. So in the same circle, if you know the radius to be 5, then the circumference is going to be 10 pi. Now because the diameter is twice the radius right here, 2r is the diameter, so I could also use the formula C is equal to D pi. Now the other thing I'm going to talk about is inscribed angles. So let's suppose I have this situation. A central angle has the vertex at the center, and it's always, the measure of the central angle is always equal to the measure of the arc that it subtends or intercepts. Now if you have an angle with a vertex on the circumference of the circle, right here, okay, call that X, and the angle intersects the circle over here, say at this point Y, and this point, say Z, and let's say that arc YZ measures an angle of say that's 40 degrees. Then the measure of angle X in this case will be half of that angle. So 40 times 1/2 is 20 degrees. This again is an inscribed angle. In the circle here, you know the measure of this arc here, take half of it, and that gives you the measure of this angle. Or if you know this angle, and you want the measure of the arc YZ, then just multiply that by 2, and you have it. Now sometimes you're going to want to find the area given by a sector. So let's say we wanted to find this area right here. So we have a central angle there, Let's say you want to find the area and you know the radius, and say you know the angle. Then one way to do it is to do this. Okay, the area, again, we're looking at this sector that's formed by this central angle and the border of the circle. The circumference is right in this area here. Well, we know the area of the whole circle is pi r squared. But we don't want the area of the whole circle. We just want the portion generated by this central angle. So what we do is we say, okay, let's say the angle generated there is theta. And here, for this formula, theta is in degrees. Theta is in degrees. We divide that by 360 degrees. And notice I'm not going to put degrees here because theta is in degrees, and then I have 360 degrees. So the degrees actually cancel out. So what this is going to give me is the fraction of the circle that generates this sector. This is the area. We're finding the area of a sector. So then all you have to do is plug in the value there to find the actual area. And we're going to look at an example for this. Right now I'm just giving you the formula. Now you can also do it this way. This is, again, I'm finding the area of sector, and that's just the region. So we're finding the area of the sector generated by this central angle again, and the circumference of the circle. This is one formula you can use. You can also use this one, 1/2 r squared theta. Now the difference between these two formulas, they're both finding the same thing. You can use it to find the same thing, the area of the sector, is that for this one here, theta is in degrees. For this one here, theta is in radians. You'll get the same thing, but you have to use one with degrees and the other one with radians. So this one, theta has to be in radians. And then you just plug in. In the same way, let's suppose I wanted to find the arc length. How long is this? Here, this portion of the circle right here. Like part of the perimeter. Here's the formula you would use. You want the arc length. So this is for arc length. S is equal to theta times r. Where theta, again, would be this angle right here. What the central angle is, you have to know that. And of course you have to know the radius of the circle. This is for the arc length. Now you can also do a similar thing that we did here with the area. So S here represents the arc length. So I could also say Sn is equal to, so what's the perimeter or the circumference of the whole circle? So you can see that if theta is 360, 360 over 360 is 1, so that just gives you 2 pi r, which is the area or the circumference of the whole circle. That's how that works. So, okay, so those are your formulas for the area of a sector. Again, theta in radians, or degrees rather, for the first one, and theta in radians for the second one over here. And if you want the length of an arc, for the first one, S equal to theta r. Theta has to be in radians. For the second one, theta over 360 times 2 pi r. Theta has to be in degrees. Let's clear this. So let's suppose that this angle is 50 degrees. Now what is this in radians? Just in case you're using one formula or the other here. So how do I convert this to radians? Well, I multiply this by pi over 180. You can see that the degrees are going to cancel out. 0, 0 cancel. So what do I get? I get 5 pi over 180. And this is without the degree. This is now actually radian measure. We don't have to put radian. If it doesn't have the degree symbol anywhere, then you know it's radian. But that's what we have. So now if I want the area of this sector, this is going to be A is equal to, area is equal to, if let's say I use the degrees, this will be 50 over 360. And this will be pi, and the radius here, say, is equal to 4. So you're given the radius to be 4. You're given the central angle. So this will be 4 squared. These cancel out here, so I get 5 over 36 times, and then 4 squared is 16, I get 16 pi. And then you can just multiply this out if you want, and leave the answer in terms of pi times the 60, or 16 rather, 80 pi over 36. And then simplify, or you can just use your calculator and multiply this out. This should come out to 6.98 square units. Now they ask you to use radian measure. Then you use the other formula we looked at. So this will be 1/2. This will be A is equal to 1/2 r squared theta, where theta is in radians. This will be 1/2. Radius is 4, so 4 squared is 16. And the angle in radians, as we saw, was 5 pi. And this was 18 here. So this is 5 pi over 18. I canceled the zeros out there. So 5 pi over 18. So then you just multiply 1 times 16 times 5 pi divided by 36. And this should give you the same thing. 6.98. So you have the option of using either formula depending on what they tell you or what you have available. But if the angle is given in degrees and you're using this formula here, you have to convert it to radians. Yeah, so these, as you can see this clearly, I did this over here, more detailed. Area of the sector of a circle, radius r equal to 4, and the central angle is theta equal to 5 pi over 18. This is the one you have. So if I use the first formula, it's A is equal to 1/2 r squared theta equals 2. So plug it in, 1/2, the radius is 4, that's 4 squared. For the first formula here, theta is in radians, that's 5 pi over 18. We do these calculations. And we get 6.98, and that's square units. And then if I use the other formula, A will equal theta over 360 pi r squared. So plug in 50 degrees. Again, the degrees cancel there. So 50 over 360. Then r is 4, that's 16 pi. We have it here. So we just multiply this out. Calculator, 50 times 16 pi. And then divide that by 360. Again, you should get, round it out to two places, 6.98. And that is in square units. And the other thing I want to go over, if you have, you want to find the arc length. So for a circle of radius r, the central angle of theta radians subtends an arc whose length is r theta. If the angle theta is in degrees, then S is equal to pretty much the same sort of thing as we did with the area. It's theta over 360. We're taking the portion of the arc associated with that particular central angle, and the circumference is 2 r pi. So if you wanted the arc length associated with the angle of 50 degrees, then this would be, using the second formula, this would be 50 over 360, and then you can cancel that out, and then r is 4, this would be 8 pi, and then we just take the calculator. This would be 5 times 8 times pi, multiplying the 5 and the 8 and the pi there, hit enter, then divide that by 36, I get 3.49. Run that out to two places. So this is 3.49, and that's units. It's not square units. It's just regular units, inches or feet or whatever it turns out, whatever units they give you, but it's just 3.49 units. So here in this case, theta was in degrees. Now if we use the other formula, S will equal to r. R is 4, that's the radius. And the angle, 50 degrees in radians, would be 5 pi over 18. Multiply it out, 4 times 5 pi divided by 18, you should get the same thing. 3.49 units again, because we're finding circumference, or the arc length in this case, of the circle. And then the last example I wanted to look at is this one here. Let's suppose I have a diameter. This is a diameter. And suppose I had a triangle inscribed in the circle. So I got this triangle here, A, B, C. It's inscribed in the circle. And I wanted to find out the angles of this triangle. So let's say angle B there, let's say this angle A, and then this angle here, say represented by C. And the center of the circle is right there. So you can consider AC. AC then would be a diameter. It's also a chord. The diameter is the largest or the longest chord of the that you can put in a circle. What are the measures of these angles? And let's say this arc here, let's say this arc right here measures an angle of, and these won't be to scale, but let's say this is 40 degrees. What are the measures of these three angles? And this will be using some of the things we just went over. So number one here, angle B, notice it intercepts that arc right there. But that's half the circle, 360, so that should be 180. So since this is an inscribed, angle B is inscribed, so it should be half the arc that it subtends or intercepts. So 1/2 of 180 degrees is 90. That's always going to happen anytime you have an angle inscribed and the sides go directly to the diameter. That's always going to be 90 degrees. So angle B is a right angle, 90 degrees. Angle BAC is also inscribed, so it should intercept or be half the arc that it subtends. So okay, the opposite arc over here is 40 degrees. Half of that is 20. So angle B, measure of angle A, I should say, should be half of 20, which will be half of 40, I should say, which will be 20 degrees. Measure of angle C then, well now we have, or to say, two of the three angles of the triangle. And of course we know that because B is right, the other two have to add up to 90, so we know that angle A and C are complementary. So if A is 20, C should be 70. And of course they all add up to 180. Thanks for watching. We'll see you next time.